Okay, let's quickly do a couple of examples. So one-step examples. Now, these situations are where we know everything but one pronumeral. Now, if you don't know two pronumerals, you pretty much can't solve equations. So you need to have enough information to know to have everything but one pronumeral. Now, if 2x equals 6, this is like saying, you know, I've got two boxes, each with a certain number of things in them, giving me a total of 6, and so, you know, it's not too hard to go, well, yeah, there must be 3 in each box. But again, we need to have a system for doing this. So we're going to do our order of operations in reverse, which means we're going to do subtraction and addition. We're going to then do multiplication and division, and then we would do exponents, but we probably aren't because of what we're keeping it pretty simple, and then we do brackets. So we're going to start off with our subtraction or addition if it's there, and then move on. So let's have a look at this one. Now, what operations are happening in this equation? There is no subtraction or addition, but there is multiplication. So what I want to do to get x by itself is I have to do the opposite thing to both sides because I've got to balance it. So if I've got 2 times x equaling 6, then I just do the opposite to each side. So the opposite of multiplication by 2 is division by 2. Now these cancel each other out. What I'm left with on my left hand side now is just x. On the right hand side, 6 divided by 2 is 3. So that's done. With this one here, now this is subtraction, so I'm going to do the opposite operation to both sides. Now there's a bunch of different ways you can write this. I'm kind of happy however you do it, as long as it's reasonably clear. What I tend to do is I tend to write plus 4 just to show that I'm adding 4 to both sides. Now I'm not doing anything to x, but I've got minus 4, and the opposite of subtracting 4 is adding 4. Now if I have minus 4 plus 4, that's going to equal 0. So these two cancel and disappear. On this side, 5 plus 4 equals 9. So all that's left on the left hand side is x equals 9. Now moving on to some two-step examples. Now with two-step examples, all you have to do is follow the order of operations in reverse again. You do one operation first, see what you've got left, and then you look at the other one. So 2x plus 3. Now the first operation I'm going to look at is the addition. So I've got plus 3 here. The opposite of that is to subtract 3 from both sides. So I'm going to go 2x plus 3 minus 3 cancels. So I've got 2x left on the left hand side. 15 minus 3 is 12. Now I'm down to my multiplication. So the opposite of multiplication by 2 is division by 2. So x is, because these cancel, x on its own is 12 over 2, which equals 6. With another example here, I've got x over 3 plus 3 equals 5. Now my opposite operation to adding 3 is to subtract 3. So, and remember, this is the first one I'm doing because I'm doing my order of operations in reverse. Take 3 off both sides, these cancel, so I'm left with x over 3 equals 5 minus 3, which is 2. Then the opposite of dividing by 3 is to multiply everything by 3. So 3 times x over 3, well 3 divided by 3 is going to cancel. I've now got my x by itself. 2 times 3 equals 6. And last one. My bad. Okay, just some more slightly more complicated examples where we've again got some two steps, but there may be something complicating things a little bit. So in this case, there's a negative number. Again, the first operation I'll consider is addition of 12. So the opposite of that is to subtract 12 from both sides. These will cancel. So I've got minus 2x. Okay, now 6 minus 12, you've got to be careful with your directed numbers here. If you're ever in doubt, just use your calculator. There's no really no problem if you wish to do that. Now, Then I've got to get x by itself again. It's being multiplied by -2. So the opposite is to divide by -2, which I have to do to both sides. These cancel. Now, you might have noticed that at every step we're cancelling something to make our one of our expressions simpler and simpler until all we've got left is our pronumeral. So now all I've got left is x. Now, 6 divided by 2 is 3. Now, directed numbers comes into play here. We've got a negative divided by a negative. Now, whenever the signs are the same, you always end up with a positive number. So I've got x equals +3 or just 3. Now, another example here that's written in a slightly different way, where I've got the same denominator for both these terms on the left-hand side of the equation. Now, this is an interesting one because it's actually harder to do this way if you've got your denominator here. Well, no, actually, let me say this another way. There are two ways you can do it. Now, one way is to think about your equation written in a slightly different form. So, because it's x over 3 here, we could write this as x over 3 minus 4 over 3, because the denominator is the same for both numbers. So we could just write it in this way, where they're now split into two individual fractions. And then we could go equals 7. Now, I can just do this one in exactly the same way I did my previous example. So the opposite of this is to add 4 over 3 to both sides. These will cancel, so I'm going to get x over 3 equals 7 plus 4 over 3. Now, you're probably going to see where this gets a little annoying. I've got to start adding fractions and stuff like that. So now I've got 8 1/3. And that can be a bit of a drag, so I'll show you an alternate way that might be better. So then I'm going to multiply everything by 3, and these will cancel, and 8 1/3 times 3 is 25. So that's one way of doing it, and it's perfectly fine, but the fractions start to get a little bit messy. So in a situation like this, now this is a slightly different case to the way I've been describing them before. One way we can think about this is the way this equation's written is it's very much like x minus 4 in brackets divided by 3. Now, if we think about it this way, well, then it actually makes sense to do the division as the first operation that we are going to reverse. So if I go x minus 4 over 3 equals 7. Now, to cancel this, obviously I've got to multiply both sides by 3. So I'm going to have 3 times. I've got to make sure I'm going 3 times all of this. So then I get, well, the thing is the 3's cancel anyway, because it's on the top line and the bottom line. So the fact that there are brackets here really doesn't make things any more complicated. Then what I've got left on my left hand side is x minus 4 equals 21, and the opposite operation to minus 4, add 4 to both sides. These will cancel, and I get x equals 25. So if you do ever come across an example where you've got the whole of the top line shares the same denominator, then you're often better just to get rid of the denominator first. Often, if you do the order of the operations in the wrong way, if you like, you're not actually going to get the question completely wrong, but it will often take you more steps to do it, especially when it's multiplication or division like this. So there are two ways of doing it. Either is completely fine, but yeah, be conscious that in this situation here, where you've got a single number as the denominator for both of them, we can often get rid of that by multiplication, and it just means we avoid dealing with fractions as much. Alright, that's the end of the first video. What I'd like you to do is to attempt the first lot of exercises, and you can speak to me about those in class during the week. Thanks.